Hello, my name is Benjamin Jones. I go to Tennessee Tech University and I am taking Physics 1 online. I'm here to talk about the study of physics and the game of football. To start off, it should be known that football is played by getting a ball from one end of a field to another while trying to avoid collision with an opposing team. Additionally, the ball used in football is occasionally kicked toward the opposing team's goal in order to secure a point. Physics is the study of how matter moves through time and space, as well as how it interacts with energy and the forces created by said interactions. These aforementioned forces take different forms in football, which include both kicking and throwing the ball, as well as on the players themselves when colliding with another player. Newton's first law. This is also known as the law of inertia. This states that an object, in this case a football, will remain at rest unless someone or something uses a specific force to move it. Alternatively, the law also states if said object is in motion, that it will remain in motion unless acted upon by an external force. Newton's first law can also be applied to the players themselves, with the most notable examples referring to larger players. The heavier and larger an object is, the more we expect the object to stay in a stable position, which explains why a large linebacker would be more difficult to move when compared to a lighter running back. When referring back to Newton's first law on a football, inertia acts on the ball by keeping it at rest if it sits on the field, as well as when the ball is picked up and thrown by a quarterback, by propelling it in the direction thrown with a specific speed. From Newton's first law, the ball should theoretically continue to travel in the direction thrown with the same speed, yet due to us knowing about the force of gravity acting on the ball, as well as players potentially catching the ball, it does not travel indefinitely with the same velocity throughout. Newton's second law. Newton's second law of motion helps determine a football's force and acceleration. This law states that an object's force is equal to its mass multiplied by its acceleration. This can be seen in the equation to the right in parentheses. F, force, is equal to N, mass, times A, acceleration. This equates to the ball's acceleration being determined by how much force the player applies in throwing the ball and the mass of the football itself. For example, when a ball is thrown by a quarterback, the quarterback applies force when throwing the ball, where the ball's acceleration increases due to it speeding up after remaining at rest. Most footballs are typically lightweight, but if a player were to throw a larger or heavier football, Newton's second law would go into effect and the heavier, larger ball would have a decreased acceleration due to having an increased mass compared to the lighter weight football. Newton's second law can also apply to the players themselves as in Newton's first law. As a football player uses his legs to move, his acceleration increases. When used in conjunction with a player's mass, the force the player exerts on another player when defending or tackling can be determined. Newton's third law. This law states that for every force applied, there is an equal and opposite reaction force. This law can be applied to a kicked or thrown ball when another player catches it. The ball applies force to the player who catches it, and the player exerts a force that is in the opposite direction but an equal magnitude on the ball. Overall, the action of catching the ball allows the player to exert the force to slow down the ball and bring it to rest and in control of the player. Yet Newton's third law is most clearly seen by the actions of the players. A good example of this would be when a smaller, wide receiver is hit by a larger, defensive player in a mid-air collision. Oftentimes, it does not appear that these players are exerting the same force, but they are. This can be found by knowing the law of conservation of momentum and momentum itself. Momentum is mass in motion and is found by multiplying an object's mass by its velocity. This can be seen in the equation on the right in parentheses. P, momentum, is equal to mass m times velocity, v. The law of conservation of momentum states that the momentum of a system is constant if there are no external forces acting on the system. When referring back to the example of players colliding, it is possible that with each player's respective mass, they also have a respective velocity, and therefore exert an equal change in momentum when colliding. Theoretically, a receiver could weigh 90 kilograms and have a velocity of 5 meters per second. This can be seen in the equation P, momentum, is equal to 90 kilograms times 5 meters per second. Conversely, a defensive player could weigh 120 kilograms and have a velocity of 3.75 meters per second. This can be seen in the equation in parentheses. P, momentum, is equal to 120 kilograms times 3.75 meters per second. When these players collide, their momentum falls to zero, yet they both experience an equal change in momentum of 450 kilograms times meters per second. Therefore, they experience the same force but in opposite directions. Despite each player experiencing the same force, however, the smaller player will usually appear to take more of the impact, it seems. This is due to each player's differing acceleration, which is how quickly an object's velocity changes. Due to the smaller player having a greater velocity, he will ultimately have a greater acceleration, i.e. a greater change in velocity, once he makes contact with the other player. This gives the illusion that a greater force was exerted upon him, even though it was not. Newton's first, second, and third law of motion explain the basic physics principles in the game of football, but it is helpful to know additional principles in this category. For example, each player running on the field displays what is called kinetic energy. This energy is applied simply by being in motion. Kinetic energy itself can be found by multiplying half the player's mass by his respective velocity and squaring it. This can be seen in the equation Ke, kinetic energy, is equal to half times m, mass, times velocity. This whole equation is raised to the second power in order to find kinetic energy. Kinetic energy can result in collisions and therefore injuries to a player, so it is important to know. Additionally, the distinct shape of the football provides unique characteristics in physics. With the ball being a prolate spheroid, there is only one way that is preferred when throwing it. If the ball is thrown sideways, there will be more surface area exposed on the ball. Due to a greater area of the ball being contacted by air particles, there is more air resistance, causing the ball to travel a very short distance. In contrast, throwing the ball with a point forward allows reduced drag and greater distances for the ball to travel. In conjunction with throwing the point forward, there is a spin on the ball. This is centripetal force, and it can be utilized to grant the ball greater stability in the air. It is also helpful to know torque, center of mass, and axis of rotation. But first, it should be known that this is often used in football and taught by coaches. Players are often told by their coaches to tackle a runner in a low position. By being taught this, it allows smaller players the chance to be able to tackle bigger players. The skill is acquired through knowing torque, a player's center of mass, and the axis of rotation. Torque is the measure of rotational force in an object. Center of mass is the point where gravity acts most on an object. An axis of rotation is the point the player's body rotates around. The player's center of mass is usually at the stomach, and his axis of rotation are his feet touching the ground. Torque is ultimately found by multiplying the applied force by the distance from the center of mass at which the force is applied. One has more torque when one makes contact at a larger distance from the axis of rotation. By being closer to the ground, the player's center of mass is closer to his axis of rotation, making it harder to move him. Consequently, he has a lower potential torque due to these combined factors. Referring back to the example of a crouched player attacking a standing player, once the crouched player, who has a lower center of mass, collides with a standing or running player who has a higher center of mass, it is easier for the crouched player to move the opposing player around his axis of rotation. As stated earlier, the standing player's center of mass is farther away from his axis of rotation when getting hit, and this allows him to be tackled more easily. In conclusion, football is a sport that thrives on knowing the intricacies of physics. By watching football, one can clearly see Newton's laws of motion be constantly displayed. By learning more about these physics principles, as well as others such as kinetic energy, air resistance, torque, center of mass, and axis of rotation, one can see how different football teams use this physics knowledge to their advantage and ultimately win games. My references are Football Physics by American Football Physics, Top End Sports. Also, Football Physics by Khan Academy, which is published by the 49ers Museum Education Program. I also have sources by Craig Freudenrich, PhD, NBC Learn, Chad Orzel, and Echo Romeo. Thank you so much.